Okay, in this video, I expand on the differences in central tendency statistics, such as an average, and variability statistics, such as a standard deviation. And it's a pretty commonly used example. You've probably seen this before, but think if we got two people that are shooting at a target. They're shooting a gun. It looks like a paintball gun, and you've got someone shooting at the top target, and what we have, they've shot 6 times. That's represented by the blue. And then if you take the average of that, and the best way to think of average is if I would turn this where it would be horizontal like a tabletop, and I balanced these 6 shots, where would the balance point be? I'm guessing it's around the yellow. So that's like the average. And then we have another shooter, and they shoot and they never hit the target. You've got 6 shots over here, so the average of their shots, again, the balance point of these 6 shots is the yellow for this. So who's the better shot? And I think most people would argue that this is the better shot. And what they're focusing on is that they are more consistent. And consistency is a qualitative term, but it can be measured quantitatively with a standard deviation. So we would say that this person would have a smaller standard deviation shot pattern than this one. And I'm going to show you how to calculate a standard deviation in just a minute. But standard deviations measures the average distance from the average. That's what it means. So if this is the average, and I looked at the distance from this point to this one, and I added that distance from this point to this one, and this one to this one, all of these, and added those up, that distance is going to be much larger than the distance between this target and the average, or this shot and the average. So this one is going to have a smaller standard deviation. So standard deviations measure variability. The smaller the standard deviation, the smaller the variability. I'll just say on a side note that there are people who occasionally say, hey, this is the better shot, but because they at least hit the target. If you were looking at points awarded, this person would score more. And the result of that is that you can see the average of their shot pattern is actually closer to the target middle than this one. In reality, though, if you would ask someone who would you try to improve, this person you could improve a lot quicker than this person. This person just needs to recite their pistol, or this one, there's probably multiple things going on here. But that has nothing to do with anything. Let's talk about standard deviations a little bit more. A standard deviation, this is the formula for it. Remember that the standard deviation is the square root of the variance. The variance is designated as S squared. That's the sample standard deviation. S squared. And how it's calculated, and don't get too caught up in this, you're not going to have to do this by hand. But it takes individual points. So in this case, think of these. There's going to be 6 of these, and for each of them, we take the difference between it and the average, we square it, we sum all of those differences squared, and then we divide roughly by how much we got, or in this case, 6 data points minus 1. And then the standard deviation is taking this number we just calculated and taking the square root of that. Okay, let's do that in Excel. Here's some data. I've just made up some numbers. And if I sum that, that's the sum. If I take the average of that, I'm using the average formula. Let's make that a little bit wider. There's the average. There's the variance, using the variance formula. And there's the standard deviation formula. And there's N. The count, which is a formula in Excel that counts how many you have and then subtracts 1. So there's the standard deviation, but all I did was just use Excel's formula stdev.s calculates that. But we could do it the old-fashioned way. If we wanted to code up this formula, we could. And let me show you how to do it. You don't have to do this, but you can use Excel. But just to show you that you get the same answer, I'm going to unhide some cells. And we're showing a lot of decimal places. We don't need to show that many. Let's just show one. No reason to confuse us. There. Okay. So here's the data set. We have 20 data points. And I calculate the average first. You have to be able to calculate the average. And all that is the sum divided by how many you got. So the sum divided by how many you got, there's your average, 10.7. And then after that, the first part of this is taking the difference, x minus x bar. It's this part, x minus x bar. Well, I can do that. I can take x minus x bar. What is x bar? That's the average. There you go. Now I'm going to copy this down. I'm going to copy this formula down, and I need to use direct referencing, not relative. So my reference to my average in C26, I need to put some dollar signs in front of that because Excel assumes relative referencing otherwise. When you put dollar signs around this, then it hard codes that cell reference. So when I copy this down, I'll copy it down one cell. You can see it referenced this. When I copied this formula down that was referencing rows 3 and 26, when I copied it down one, it's referencing rows 4 and 26. It let this one slide, so my reference at C3 now is reference C4, but because I hard-coded the C26 by putting dollar signs in front of it, it's still, and then I copy that all the way down, you can see at any time it's always referencing C26. Okay, I really don't need these. These aren't that important. What's more important is I've got to follow the formula, and I need to take that x minus the average and square that. So that's what I've got over here. This is equal to this number, x minus x bar, square it. And that's, you can square it by just times itself. That's one way. Or you can raise it to a power, which is shift 6, raise it to the second power. That's how you square something. And I copy that down. And that is all of my x minus averages squared. And if I sum that, that's what I have here. I'll do it again. If I sum these, that is giving me the top part of this. That's what this symbol here means, this Greek uppercase S. That means sum. So I've summed all those. And then I divide by n minus 1. Divide by n minus 1. That's what this part of it is. So that's what I've done here. Take my sum divided by n minus 1, which is 19. And look at there. The variance that I calculated just using the formula is identical to the variance calculating the long way. And then I can take it the next step and just take the square root of my variance to calculate my standard deviation, and you can see that's identical to what use the Excel. So you can code it up, you don't have to, but I wanted to give you a feel of how you can write some formulas and copy and paste things in Excel. Thanks.